Today we will discuss the topic ionic bond. It's very important topic in metals and non-metals. Ionic bond, it is the force of attraction between two atoms due to the transfer of electrons. That means when two atoms come closer, the electron will be transferred from one atom to atom, resulting formation of positive charge and negative charge. When these two opposite charge will come closer, forming the ionic bond. And ionic bond is formed due to the force of attraction between cation and anion formed due to transfer of electrons. So generally we can say it is the force of attraction between two opposite charged ions produced due to transfer of electrons. For example, formation of sodium chloride. If you see the sodium, the electronic configuration is 281 and chlorine is 287. Sodium, as it has one electron in its outermost shell, it has tendency to lose this electron, and chlorine has 7 electrons in its outermost shell. It has tendency to accept 1 because to satisfy the octet rule. When it satisfies octet rule, then they will be stable. So when sodium and chlorine come closer, sodium will lose 1 electron and chlorine will accept that electron. So after losing 1 electron from sodium becomes positive charge and chlorine becomes negative charge. So you see, during this transfer of electron from sodium to chlorine, sodium produce sodium ion and chlorine produce chloride ion. You see the transfer of electron. In this slide here, sodium is losing 1 electron, that's yellow electron of sodium is transferred to chlorine. Now sodium becomes positive charge and chlorine becomes negative charge. Sodium becomes sodium ion and chlorine becomes chloride ion. Now chlorine is satisfying its octet rule. It has 7 electrons, that red electrons, and accepting 1 electron from sodium become 8 electrons, and sodium has 281 extra electron in outermost shell. So it loses its 1 electron, extra electrons. That's why it also satisfied 2-8 configuration and it satisfied 2-8-8 configuration. So after losing electron from sodium become positive charge and chlorine become negative charge. So it is called chloride ion. Then these two opposite charge ions will attract each other and forming ionic bond. Then you see this here, the fighting between two ducks. Here the smaller one and the bigger one. Smaller, when smaller is coming to the bigger one due to its greater power, it is taking the bone from it. Then the smaller one is very closer to bigger one because both are attracting each other for bone. That's why it is also one indicate the transfer of bone from smaller one to bigger one. Like the sodium loses its electron to chlorine, so chlorine becomes Cl minus and sodium becomes Na plus. So after similarly here, smaller dog loses its bone to the bigger one. So due to this transfer of bone, a bond takes place, a relation is developed between the smaller and bigger one. Similarly, sodium and chlorine come closer and sodium becomes Na plus and chlorine becomes Cl minus, then both attract each other forming sodium chloride. This is called ionic bond. Okay, then you see the atomic structure of sodium. Sodium has 11 electron, 2 electron K cell and 8 electron L cell and 1 electron in the L cell. M cell, that is third cell. If similarly chlorine has 2, that is total 7 electrons in outermost cell, 2, 8 and 7. So it required 1 electron to satisfy octet rule, and when it loses 1 electron sodium, it becomes 2-8. It satisfies octet rule. So when these two atoms come closer, then sodium is losing 1 electron to chlorine, then sodium become 2-8 and chlorine become 2-8-8. So due to this transfer of electrons, sodium become Na plus and chlorine becomes Cl minus. Then both two ions attract each other due to electrostatic force of attraction. Opposite charge ions attract each other forming ionic bond. What are the other examples of ionic compound? magnesium oxide, potassium sulfide, ammonium chloride, calcium phosphate. Here the cation anion, here cation is magnesium 2 plus, anion is oxygen 2 minus, like this Potassium K plus, sulfur 2 minus, like this NH4 plus, Cl minus. So these are the ionic compounds produced formed due to formation of cation anions in the compound. You see the formation of magnesium chloride. As magnesium has 12 electron 282 and chlorine has 7 electron 287, so magnesium has tendency to lose 2 electron to become 28, that is neon. And here chlorine has 287, it has also demand 1 electron due to shortage of 1 electron, but magnesium donate 2 electrons, but chlorine cannot accept 2 electrons because it demands only single electrons, so one is shortage. That's why magnesium donate 2 electron to 2 chlorine atom. When 2 chlorine atoms come closer to magnesium donate 2 electrons to 2 chlorine atom, so that equally the electron distributed to 2 chlorine atoms, then chlorine become 288 after gaining 1 electrons, and magnesium become 28. So when magnesium loses 2 electron, it becomes Mg2 plus after loss of electron, and chlorine accepting electron becomes Cl minus. When these two Cl minus come closer and with very close to the magnesium ions, then due to the opposite charge ions, they attract each other forming the ionic bond. Ionic bond is the force of attraction between opposite charge ions due to formation of transfer electron. So this is called formation of magnesium chloride due to transfer of electron from magnesium to chlorine. So you see that this is the structure of sodium chloride crystal. You see the definite arrangement, systematic arrangement of Na plus Cl minus in the crystal. Due to definite arrangement, due to systematic arrangement, this solid has a fixed structure. So this is a crystal structure of sodium chloride. How they arrange, you see sodium plus this violet color and green color Cl minus are in systematically arranged in the crystals, so forming sodium chloride crystals. And what are the properties of ionic compounds? Ionic compounds are produced between the cation anion formed due to transfer of electrons. So what are the characteristics of ionic compound? First characteristic of ionic compound is they have high density. Why the ionic compounds have high density? Because they are very strongly attract each other. Ions will be very close to each other. That's why they have high density. Then second property is they have high melting and boiling point. The properties boiling point, melting point is very high because the opposite charge ions attract each other by the strong electrostatic force of attractions. So more temperature is required to break the attraction between the plus and minus. That's why high melting and boiling point. And almost all ionic compounds are solid at room temperature. All are solid at room temperature. This is a very important characteristic of ionic compounds. Then these ionic compounds in the molten state or aqueous solution, they conduct electricity. That means ionic compounds are water soluble. This solution conduct electricity. This is a very important characteristic of ionic compound, that they conduct electricity. Then another important property, it conduct electricity in molten state and in also aqueous solution because they produce free ions. In water they produce free ions. Due to formation of free ions, they move in the solution, so it conduct electricity. And these ionic compounds are hard and brittle. If you touch it, it becomes hard. It will feel it is harder because the ions are very strongly attract each other. Due to high density, it is hard. Then brittle nature. Brittle means when you give the force, give the pressure, it breaks. So these ionic compounds are brittle. So what are the important properties of ionic compounds? They are water soluble, they have high density, high melting and boiling point, and they are all solid at room temperature. They are water soluble, and the solution conduct electricity, and also the molten state of the ionic compound also conduct electricity, and they are very hard and brittle. So these are the very important characteristic of ionic compounds. Then you see These are the very systematic, definite arrangement of cation anions in the crystal. But if you give the stress, when you give the pressure, then this layer displays from one place to another. When the layer displays, then what happens? The similar cations will come closer due to so they repel each other. Due to repulsion, the layer separated from each other, so it will becomes brittle. Why they brittle? Why ionic compounds are brittle? When the stress will given, due to the stress, the layer displays from one place to another. Then the like charge ions will come closer. They repel one another, so the layer separated from each other. That's why they are brittle. Then how to identify the compound as ionic compounds? All ionic compound, how can we identify the compound as ionic? All ionic solids all ionic compounds are solid at one point. This is a very important characteristic because they all are solid. That means we should not think that all solids are ionic compounds. No, all ionic compounds are solid. So these are important characteristics. Then second thing is that it is a brittle nature. When you give the phrase, it will be brittle. That is another characteristic of ionic compounds, and these are also very hard also. Then third is when it will be heated, it requires high temperature to melt and boil also. That melting point and boiling point is very high of ionic compound. That is an important characteristic of ionic compound. Then another thing is it conduct the solution. They are water soluble. Another point is ionic compounds water soluble and they conduct electricity. That is another characteristic of ionic compound. You can identify if the solids ionic compound in aqueous solid, soluble in aqueous, soluble in water and conduct electricity. That means these are what? Ionic compounds. Another important is that when it dissolve in water and this solution conduct electricity, the conductivity is very high compared to the other solution. Ionic compounds, water soluble, they conduct electricity and the conductivity is very high. That means the compound is ionic nature. So these are the very important identification characteristic of ionic compounds. Okay.